We're going to take a look at our homework from last night, worksheet number 6. Specifically, we're going to do questions 4, 7, and 8, starting with number 4. Two identical charges are separated by a distance of 1.00 meters. A repulsive force of 3.60 newtons acts between the charges. What's the magnitude of each of the charges? What we know here is that Q1 equals Q2 because they're identical charges. Let's just call it Q. Since they're the same values, let's just call them both Q. We know that there's a force, and we know that there's a distance that separates them as well. Let's say F is equal to K Q1 Q2 over R squared. But what's the value of Q1 and Q2 again? Connor, what's Q1 and Q2? We're just calling them Q. So let's make it K times Q over R squared. But what's Q squared? Mason, what's Q squared equal to? Whoops. What's Q times Q equal to? I may have given it away. What's Q times Q equal to? Q squared, right. Some people will say 2Q. Okay, 2Q is Q plus Q. Q squared is Q times Q. That's what we got there. So it's F is equal to K times Q squared over R squared. And we're solving for Q here, so we take the R up by multiplying. F times R squared equals K times Q squared. The K goes down by dividing. F times R squared over K equals Q squared. And then how do I find Q? Square root it, right? Q is equal to the square root of F times R squared over K. Okay, you guys should be able to plug the numbers into this, right? Watch one thing though, guys. Watch one thing that people still, even though I've mentioned this and every time I do it on the board, I show you this. I don't necessarily explicitly state it, but when we see a number like K on the bottom of a fraction, when K is a denominator, or any other number that has an exponent to it, like scientific notation, 10 to the whatever, when it's on the bottom, even when it's on the top for that matter, but especially when it's on the bottom, don't enter it the way that you guys like to enter it. Don't enter it as 8.99 times 10 to the 9. Don't do that. If that's on the numerator, that will work. I'm going to suggest you don't do it anytime. Don't enter 8.99 times 10 to the 9 that way anytime, but especially when it's on the bottom. Enter it this way, 8.99 EE9. So second function, EE9. Okay? It looks like it's the same value. Sure enough. But if it's a denominator, then it's not going to work out. Okay, if you do it the first way, then it's going to assume that you mean to multiply everything by 10 to the 9, not just the bottom by 10 to the 9. Okay, so use my way, at least on the denominator, but preferably use it everywhere, numerator and denominator. Okay, let's actually solve this. Let's solve this both ways, the wrong way and the correct way, just to show you how it works out here. F is 3.6 newtons. Actually, let's go square root of 3.6 newtons times the distance squared, 1 squared, divided by, let's say, 8.99 times 10 to the 9. Is that going to give you the right answer or the wrong answer? We get a value of 20011, okay, which is the wrong answer. Now watch if I do it the other way. Square root of 3.6 times 1 squared divided by 8.99 EE9 and that bracket. Now I get 2.00 times 10 to the negative 5. So 2.00 times 10 to the 4 versus 2.00 times 10 to the negative 5, which is the correct answer. Does that make sense? Okay, in the first way, it multiplied the whole thing by 10 to the 9, not the denominator. But in the second way, your calculator assumes that 10 to the 9 goes with that number and only that number. All right, so please do it that way. Please do it that way. Okay, we wanted to do number 7 and number 8 as well. 7 says a charge of 2 coulombs is touched to a second charge of 6 coulombs. Then with a neutral object, The first charge is then separated from the second charge by a distance of 5 times 10 to the negative 2. What's the force that acts between them? This is one of those questions where they touch and then the force. Then we want to find the force. So it's two problems. Let's do our little chart to find out what the charges become, and then let's find the force. Charge 1, charge 2, charge 3, and remember we like to tally up the total charge along the way as well, just to make sure that it's working, we're doing it right. Charge 1 is 2 coulombs, charge 2 is 6 coulombs, and then neutral. 1 and 2 touch each other. What did 2 and 6 become if they balance out? 4. 4 and 4, right? So we got 4, 4, and 0. And then it says the first charge, the first charge touches a neutral object. It should really say they're separated in between. That's just my fault in the way that I wrote that question. It should say that they're separated in between. When 4 and 0 touch each other, what do they become? 2 and 2. So 2, 2, and then this one is 4. Let's just tally up the totals just to make sure. 2 and 6 is 8. 4 and 4 is 8. 2, 4, and 2 is 8. So looks like we're good. What's the force that acts between the first and the second now? We're going to say F is equal to K Q1 Q2 over R squared. It's 8.99 times 10 to the 9 times 2 times 4 over 5 times 10 to the negative 2 squared. Again, here's another one of those spots where it's important to use the EE button for the exponent because it's a denominator, right? My suggestion, again, is always use that for scientific notation, but especially on the bottom, like in this case. We get a force here of 2.88 times 10 to the 13 when we do that math. So pretty big force. A pretty big force here. 10 to the 13 newtons. Question number 8 is similar to this, except we've got exponents here. Charge 1, charge 2, charge 3, and the total. 1 is 1 times 10 to the negative 5, negative 2 times 10 to the negative 5, negative 3.5 times 10 to the negative 5. We add those up, and we get, what is that, 4.5? Negative 4.5 times 10 to the negative 5. Okay, is that good? All right, what does it say here? 1 touches 2. 1 and negative 2 balance out to be what? Negative 0.5, good. Negative 0.5, really times 10 to the minus 5, right? We'll worry about that later on. And then it says, it should say they're separated. Then it says 2 touches 3. Negative 0.5 and negative 3.5. Add them up, divide by 2. It gives me negative 2 and negative 2. Let's just add everything up to make sure it works out here. Negative 0.5, negative 0.5, negative 3.5, negative 4.5 times 10 to the minus 5. Negative 4.5 times 10 to the minus 5. Looks good. What's the force between 1 and 3 now? It's K, Q1, we'll call it Q1, Q3 over R squared. 8.99 times 10 to the 9 times 0.5 times 10 to the negative 5. Notice I dropped the sign of the charge. You're going to see why shortly, why that's really important to drop the sign of the charge in this or any other equation for that matter. 2 times 10 to the negative 5, don't forget that exponent there. Divided by R, which is 2 times 10 to the negative 3. Once again, use that EE button on your calculator. If you do that, you should get 2.25 times 10 to the 5.